So we're asked to determine the molecular shape of a molecule when we are provided its formula. The first step is to draw the Lewis dot structure, and then we're going to apply VSEPR. First step in drawing the Lewis dot structure is to count up the total number of valence electrons. So we have 3 chlorine atoms. Each chlorine atom is going to provide 7 valence electrons. So 21 valence electrons from the chlorine. Arsenic, we have one of those. It is in group 5, so it provides 5 valence electrons. So we have a total of 26 valencies. We're going to make it easier on ourselves by dividing by 2 so we know how many electron pairs we have. All right, so we have 13 electron pairs, and we are provided a skeletal outline. First step, we want to connect up all atoms. That uses 3 of our 13 electron pairs. So the remaining 10 pairs we use to satisfy the octet of both arsenic and the chlorine. So we've used 3. Here goes 4, 5, 6, 7, 8, 9, 10, 11, 12, and we have 1 electron pair left to satisfy the octet of the arsenic atom. So each atom here has a complete octet of electrons. We can see how if we look at chlorine. It has 4 electron pairs associated with it. We remind ourselves that electrons involved in bonds count towards the octet of both of the atoms in the bond. So this pair of electrons counts both towards chlorine and towards arsenic. So we see that all of these chlorines have a complete octet. The arsenic also has a complete octet because it has 1 pair of non-bonding electrons, that counts as 2, and each of these 3 bonding pairs counts as towards arsenic's octet. So arsenic has 2, 4, 6, 8. All the chlorines have 8. This is a happy molecule. It has all of the atoms have a complete octet. So now we apply VSEPR. In the VSEPR, we look at our center atom, and we see that it has 3 bonding pairs and 1 lone pair. So it's of the type AX3E. The result is that our electronic structure is based on a tetrahedral. One of the positions within this tetrahedral is taken up by a lone pair. So when we consider the molecular geometry, we fill one of those tetrahedral spaces with a lone pair, and what results in terms of molecular geometry is a trigonal pyramid. And that's our answer.